Hey again. Today we're going to be learning how to separate mixtures of ions by using a precipitation method. Sometimes this is called a qualitative analysis. What it does is we use experiments to determine which ions are present in a substance, and we can also use experiments and procedures to remove certain ions individually from a solution. So I've put out 3 steps here on how to remove cations. You can also use this to remove anions from a solution separately. So the first step in doing this is find an anion that will precipitate only one of the cations, and then you get rid of the precipitate that formed. And you can do this through filtration and stuff like that. You can use a filtration and then have the precipitate or the solid, and then dry that out and remove it, and then just kind of repeat doing this. So let's pretend an example of this to get a visual of it. Let's pretend we have a solution full of three types of cations. So we have maybe a solution full of A plus cation, B plus cation, and C plus cation. So what we can do is we can find an anion that will precipitate only one of these cations. So maybe let's pretend an anion like bromine or bromide anion. So Br minus is, we can take this and we can put this into the solution. So Br, and let's, with our fictional cation B plus, this will be soluble. B plus and Br minus is soluble, and Br minus and C plus is also soluble. But however, Br and A, so let's pretend we have this fictional thing of ABr, forms a solid. So what we can do is we have found an anion that precipitates only one of these cations. It only precipitates A plus. Okay, and since it precipitates only A plus, we add this, and then what we can do is we can filter this out, collect, so we can take this solution and pour it through a filter, okay, and we can collect our precipitate into a filter. So this goes into a filter, and this goes back into a beaker, and we have collected in here. Our precipitate would be a Br solid, and then left in our solution will be B plus and C plus. Okay, and then we can do this one more time and find another anion that will only remove one of these cations, and we do it again. Take this, put it through a filter, and get another precipitate, and then we just get another. Maybe this time it'll filter out B plus, and then all we have is a solution left with C plus in here. Okay, so we just keep repeating this method, and we can individually remove one cation each time, each step we go through. So let's look at more of a an example using this method in order to remove certain cations from a solution. Okay, so here's a question we have. We have a solution that contains calcium, Sr plus 2, and Ag plus, or silver. And the question asks, what compounds can we add, and in what order to separate these cations here? So we have calcium, strontium, and silver. So let's find one of these that will, something where only an anion that will only remove one of these things here. So let's go through it right here. So we have here, here's one right here. So if we add chlorine, bromine, and iodine, it'll have low solubility with silver, but for everything else, it'll have high solubility. So for calcium, it'll be soluble. For strontium, it'll also be soluble. Okay? So let's write this. We can write either any one of these three right here. So I'm going to write down the first one right here, and that's chlorine. So I'm going to write down Cl minus. And I made a table right here just to make sure everything is a little bit more clear. So here, this will be soluble, but chlorine and silver, as we see here, chlorine and silver is going to be low solubility, or in other words, a precipitate is going to form. So we're going to write here a PPT, or precipitate. Okay? Now, if we add chlorine to our solution, chloride ions to our solution, it's going to remove the silver. And now our solution is only going to contain calcium and strontium. So we can find another precipitate that'll remove these things. So here's one right here. This one removes silver, calcium, and Sr2+. Okay, it removes all three of them. So we could use that one, but it won't separate calcium and strontium here. It won't separate these two. So let's keep on going here. We have here sulfide, which removes calcium and strontium here. So again, it won't separate these two again. Okay, and let's go to our next one right here, and we see hydroxide. It is soluble with Sr, but for everything else, it is low solubility. So we're going to write here. Let's try using hydroxide, or in other words, OH minus. What we see here is that for almost everything right here, it's going to be low solubility. So for calcium hydroxide, it's going to form a precipitate. Okay. For silver, it's also going to form a precipitate. But again, we see here, this is soluble. So hydroxide plus Sr is going to be no precipitate is going to be forming. And for the last one, let's go back up to this one where we see all three of them are here, and we can add this one, SO4 2 minus. Okay, and a precipitate would form for all of these. Now, so the question says, what compounds can you add, and in more importantly, what order? This is really important on what order you add them in, because if we add our sulfate first, then everything is going to precipitate out all at once. And if we add our hydroxide first, then these two things are going to precipitate out together. So order is very, very important. So the first one we add, so if you're given a question like this on a test, you should say, first add chlorine ions or chloride ions and filter. So first add chloride ions and filter. A little bit messy, sorry. So that's the first one we do. The second one we do is then we add, so now if we add the chloride ions, we precipitate out the silver, and all that is left in our solution is calcium and Sr2+. And so the second thing that we add is hydroxide, because we can separate these two by adding hydroxide, and that'll precipitate out our calcium. So then second add OH minus, okay, and filter, of course. So again, first when we add our chlorine and we filter, the filtrate, or the solid that we get, is AgCl. And then the second, when we filter our hydroxide, we get the solid that we get after that is calcium hydroxide. And then the third thing we add, finally, we add our sulfate. And what we would get is, we would get, oh yeah, and sorry, and filter. And what in the filter, what we would see again is SrSO4. Okay, so first add this, then this, then this, and there's multiple answers you can add. And instead of adding chloride ions, you could add bromide ions or iodide ions. Yeah, and also too, there's a few other small changes we can make too. We could use, let me see, we could probably use sulfide in here somehow. For our final step, we could probably use sulfide too for step 3, because that does these two, even though if we use chloride first, that would remove this, hydroxide second, and then we could use sulfide as well for our last step. So there's a few different ways to answer these questions. Okay. Let's look at take a look at this problem. Try putting the video maybe on pause. See if you can figure out this question. A solution contains silver and lead-2 ions, and how can you precipitate out one of these cations? Okay, so try taking a look at this table and see if you can see how we can separate silver and lead-2. Okay, so hopefully you did that. And let's take a look at what we came up with here. So we see here that silver and lead will precipitate out if we add chlorine, bromine, and iodine. Now this doesn't help us that much because they will both precipitate out, and we want to separate them. Okay, so we're looking for one where silver will precipitate out but not lead, or lead will precipitate out but not silver. Okay, so this one both will precipitate out, so any of these three answers, none, these ones won't be it. Okay, again, here's the next one. Silver and lead is a low solubility, so both will precipitate out. That doesn't help us either. Now, silver is not soluble here, nor is lead soluble here, so they're both going to precipitate out if we add sulfide. So again, this one is not going to help us. And our next one right here, hydroxide, again, silver's not up here, nor is lead up here, so hydroxide, both are going to precipitate out, and this one doesn't help us. Again, silver and lead are not up here, so they're both going to precipitate out. So this one is not going to help us. So this is a bit of a trick question. How can you precipitate out one of these cations? And the answer is, well, based on just this table, we can't separate silver and lead. Now there might be another chemical out there that is not on this table, where one of them will have low solubility compared to the other, which will be soluble. But based on the table that we're given here, we can't separate them. Okay, so a bit of a trick question. So on your test, you could write something like, based on table, based on this table, these cannot be separated.